Now it's time to talk about trinomials. So trinomials, as I said before, comes in the form of ax squared plus bx plus c. Now look at this example. Though we have y and not x, it doesn't mean anything different. Are just variables, a and b just represent regular integers, right? So a, b, and c, they are just numbers then. But the x just are variables. So it could be ay squared plus by plus c, right? Now, the first step in solving trinomials is that a, a right here, must times c, a times c. So, as I said, that a is really an integer. So when we say a times c, that's 3 times 6, negative 6 that's going to give me, when I multiply them, that's going to give me negative 18. Negative 18. The next thing that we want to do is that as we're factorizing, is that we try to find the factors of 18, right? So when we're finding the factors of 18, we're searching for, listen carefully, we're searching for two numbers that when multiplied together gives us negative 18. And those same two numbers must add to give me positive 7y. Now, this is not something important. The only way to get a negative when multiplying is to have one positive and one negative. If we have two positives being multiplied, that's going to give me positive. And if I have two negatives being multiplied, that's also give me positive. So one have to be a positive and the other must be a negative. So having that understanding, we're going to search for two numbers, right, that when added or subtracted gives us positive 7. So what are those two numbers? So in listing out the factors of 18, we know that we have 1 and 18, as 1 times 18 is 18. We also have 2 and 9. 2 and 9, right? What else do we have? We have 3 and 6. So 3 and 6 is 18, right? So we have these factors. So we have 1, 2, 3, 6, 9, and 18. So those are my factors. Let me just write them out. 1, 2, 3, 6, 9, and 18. So in listing out the factors of 18, if we look carefully, when we look at our pairs, we have 1 and 18, 2 and 9, 3 and 6. So if we were to look at the 3 and the 6, if we were to add them, it gives us 9, right? If we were to add them, it gives us 9, so we can't use that. If we were to add these two as well, it gives us 11, right? However, if we look carefully as well, is that if we had a negative 3 right here and a positive, because we're looking for a negative and a positive. So if it was a negative 3 plus 6, that will give me 3. We already know we can rule out this one. So here now, if we had a negative 2 and a positive 9, then we would actually get a positive 7. So in this case, the pair that we're going to use is 2 and 9. Also be mindful that the 9, the bigger one, since we're doing a positive 7, the bigger one will have to be the positive and this lower one would be the negative. There are some cases where that is not so, where the bigger one is going to be a positive. But the fact that this is a plus, this is a positive 7, the bigger one have to be a positive. So we are said that we are going to use the 9, the bigger one, for the positive. So we're just going to write back the 3y squared, that's 2y squared plus 9, and we write 9 in the form of b. So that's 9y minus 2y minus 6. Okay, so that's what we have there. So if we look now, is that we literally have a quadratic expression. So when we see the quadratic expression, remember that we're going to do them in two terms and two terms. So we're going to start with, I'm just putting this bracket just to show the border that we're actually doing that in border, but just don't put the bracket there really. So 3y squared plus 9y. So what is common between 3 and 9? The factors of 3 are 1 and 3. So 3 is a prime number. And the factors of 9, so for 9 is 1, 3, and 9. So the highest common factor between 3 and 9 is 3. So we're going to take out 3. And if we look at the index, we see that y is the one with the lower index. So we take out the y. So in dividing 3 into what? 3y and 3y squared, now the 3 is going to cancel out this 3. This y is going to subtract 1 from this, gives us 1. So all I'm left with is just y to the power of 1. So we just have y. And plus 3 into 9 is going to give us 3 times, and y is going to cancel out this y. This is going to be 3. So all I'm left with is just a 3. And I'm finished with that, with those two terms. So here now we have 2y and negative 6. So we're going to keep the negative. And what is, if you look here, is that we don't have any y here. So we cannot take out our y in this, in between these two terms. So, but we look at the coefficient, we see the factors of 2, 1 and 2, and the factors of 6, 1, 2, 3, and 6. So we can take out 2 because 2 is the highest common factor between both terms, or both coefficients there, both integers. So we're going to take out the 2. In taking out the 2, so negative 2y is going to cancel out. Negative 2y is going to cancel out this negative 2 right here. So this is going to be canceled out. So we have negative 2 there. That's going to be canceled out. So I'm left back with y. Negative 2 here, you know, a negative into a negative is going to give me a positive. And 2 into 6 actually goes 3. So that's how we get it. Now remember that when I did the last quadratic expression in our lesson, is that we identified that the both brackets have the same expression, y plus 3, y plus 3. So we could just simply group everything now, 3y minus 2, and here we actually have y plus 3. So that now is literally my final answer for solving trinomials. Now, there is, when you look at trinomials, there are different aspects to it. So let's look at another aspect. All right, so let us look at another aspect of solving trinomials. Now, in solving trinomials, if we were to look carefully, we have 2x squared minus 5x plus 3. Again, a times c is the first step. So this is 2. Well, this is a positive 3, just checking to ensure that that is it. So this is a positive 3. So we have 2 times 3. So that is actually going to give me a positive 6. So that's a positive 6 right there. Again, what's my next step? My next step is to find two numbers which are factors of 6 that when added or subtracted gives me negative 5x. So in listing out the factors of 6, we know we have 1 and 6. We also have 2 and 3, right? Now, as I said before, is that we have to find two numbers when multiplied together gives us a times c, which is positive. So we have to find two numbers when multiplied together gives us positive 6. So the only way to get a positive when multiplying is to have one. We have to be multiplying two positives or two negatives. Those are the only way we can get a positive 6. Now, if you look here, is that we have a negative 5x. So, in looking at our factors here, if we had both been positive, we cannot get back negative 5. So, this would give me 7 and this would give me 5. But if both are negative, this would give me negative 7 and this one would give me negative 5. So, the pair that we're going to be using is the negative 2 and the negative 3, right? So those are the pairs that we're going to be using. So negative 2 and negative 3 are our pairs. So we're just going to rewrite the 2x squared minus negative 3x minus 2x plus 3. So that's what we're gonna have there. So again, we now have our quadratic expression. So in having our quadratic expression, when you look carefully, we're just gonna work out these two. And what is common between 2 and 3, only 1 is the common factor between 2 and 3. So there's nothing else to take out but the 1. But we see that the variable x is common among both terms. So in taking out this one now, that we take out the one with the lower or the lowest index. So x here, and then now, as we say, we normally divide it. So if we're dividing x, we're literally subtracting it. So that's left me with just x. Oh, sorry, I left out my 2. So I'm left with 2x. 2x right there. Here now, minus 3x, right? Just going to write this bigger so we can see it. It's 1x, 2x. So negative, this x now is going to cancel out this x right here. And of course, 1 into any number is just the self, so all that we're left with is just the 3. And I put back our negative sign there. And again, there's nothing between the 2 and the 3 except 1. So we just take out the 1. So if you look here, 1, we can't take out the x, so we just take out only the 1. So in taking out negative 1, 1 and this is going to be a positive 2. So all that we're left with is positive 2x. And then negative 1 divided into negative 3 is going to give me a negative 3. So all that we're going to have now is that we're going to group these two. We have 1x, or you can just have the x minus 1 in one bracket, and in another bracket we just group these as 1, as 2x minus 3. So that is another way to look at trinomials. Is that the main thing that I want to emphasize here is really the signs, is that the two numbers must add to give us negative 5x, and it must, when they multiply together, they give us a positive. Now let us look at a scenario wherein both of them are negative. So we look at one when this was a positive and this was a negative, and now we just look at this being negative, this being positive. Let us see how it works when both terms between bx and c are negatives. So let us talk about in cases where both terms, both bx and c, are negatives. So again, the first step is a times c, which is actually 2 times negative 3, which is going to give me negative 6. Looking at it again, so we have negative 6. So in having negative 6, we have to list out the factors of 6. And again, in listing out my factors, I have to bear in mind that the only way to get a negative when multiplying is to have one positive and one negative. That's the only way to get a negative 6, right? Or to just get a negative for that matter. So the only way to get a negative is to have one positive and one negative. So in getting negative 6, we have to list our factors of 6. So we have 1 and 6 and 2 and 3. So as discussed before, I said that the only way to get a negative when multiplying is to have one positive and one negative. So we have to have one being positive and one being negative. So the first question we did is that this was a positive 7. And I said that we have to use a bigger number to represent the positive. But the fact that this now right here is a negative 5, it means that the bigger number is going to be the negative and the other one is going to be the positive. So here, if we add negative 3 plus 2 or 2 plus, sorry, 2 minus 3, that's going to give me negative 1. And here now, if we have 1 minus 6, that's going to give me negative 5. So the pair that we're going to use in this case is 1 and 6, with the 6 being the negative. So we're just going to rewrite 2x squared minus 6x minus, sorry, plus x, right? So we don't have to put the 1 there. We're just going to put plus just under the x. All right. So continuing now is that we have our terms. So what is where we have 2 and 6. The highest common factor between 2 and 6 again is that 2 is a prime number. List out the factors of 2, that's 1 and 2. 6 is also a prime number. So that's 1, 2, 3, and 6. So the highest common factor there is our 2. And again, amongst the variables, we take the one with the lower index. So take out 2x. So this 2x now, the 2 is going to cancel out this 2. And then we're going to subtract one of the x from here, which is just going to give me 1x. So I'm left with just the x. Here now, 2 into 6 is 3, and x is going to cancel out this x. So all I'm left with is just a 3. Right? So here, looking at this now, is that when we look carefully, we see that there's nothing amongst the, well, you know that is actually 1x, right? So, and 3. So there's nothing that is common among both coefficients of the 1 and the 3. So, you know, that's just going to be 1 right there. And the next thing now is that dividing positive 1 here and dividing positive 1 here. So that's just going to give me back x. And of course, 3 over 1 is just 3. So there we have it. 2x plus 1 in one bracket. And then we're just going to rewrite these as one bracket. And there you have it. We actually solved that form of trinomials. So this is literally how trinomials they are done in the form of ax squared plus bx plus c. This is how we do it. Just remember what I said about the signs. That is really the crucial part. Okay.